Yeah, so hi guys, welcome to the second video. The main mode of this video is to discuss multiple things with respect to the operating systems and now why we need the operating system. So once the OS is like get put it up, so we need to log in with some user. So to access operating system, it's like kind of mandatory thing. You need to log in with some particular specific user. So in our case, we the during the installation of RHEL, so it's we are created two users. One is root, another we created with the name called D Verma, and we set the password of this both the user there is some XYZ and we use this password to log in or to interact with that particular operating system. So let me log into that particular operating system once, then we'll discuss the things. So we need to log in with the root. So why root? Uh, so let me tell you why root. So in the world of Linux operating system, root is a user uh, that is called as super user. Why super user is we can do any task, any means any task like let's say creating the user or like deletion of the users or like creating some attaching some IO devices and do some tasking on over them or like changing like we need to change the password of some existing user that all we can do or like changing the some authentication related things or like multiple things we can do in the operating system we can discuss as we move on to this particular training. Yeah, so but root is a user that is called as a super user. Super means we can do like any super things that's possible in the world of Linux operating system, so that's why we logged in with the root. Now let me discuss two things. So there is generally in the world there is the terms are almost same, but let me tell you the exact difference. So the term is program, program versus process. Before that, we need to understand the difference between uh, storage unit and computing unit. Computing unit. So storage unit, as I told in the last video, is we call the hard disk as storage unit, and the RAM and CPU together are called as computing unit. So it's obvious by the name also, but let me tell you a difference. So if you want to permanently store some things, so one second. So if you want to install or like we need to keep some things permanently stored somewhere in the operating system or somewhere in the machine, then we will use a hard disk. So there are multiple type of hard disk available in today's world. That is like SATA hard disk or SSD hard disk. So, but the work of both is like same. If you want to store things or like store things and store the applications, storing the program files permanently, then we need to use the storage unit that is hard disk. Now, what is the difference between SATA and SSD? It's like it's there's a difference in input output operations. Now, what is the input output operation is like how fast you can read or how fast you can write to this particular hard disk. If you want to read more, you can go to the Google and like read more. There are direct blogs of this. Now, computing unit. So, RAM and CPU. These are computing units. So if you want to execute something, if you want to execute some application or like some program, then we need this computing units. Let me take some example of real world. So there is a mobile. This is in a mobile. Okay. And in this mobile, first things are like it's come with RAM, CPU. If you are aware of, like, hard disk is also there, but hard disk name is got changed, like it's ROM, not RAM, it's ROM. And some other things are also there, network card and everything. And on the top of it, we are running with an operating system. Operating system maybe like can be what say Mac. Mac is like of more respect to uh, uh, computing world, but like we can say iOS, Android, or there are many more operating systems also there. And there is one some few applications are running or few programs are there. So let's say you want to install some game, and game name is like you can say PUBG. So as soon as you install the PUBG, you need to kept it somewhere in your mobile so it will be available permanently. Yeah, so you install it from the Play Store and somehow it install in the hard disk or ROM. More respect to mobile term, but hard disk, let's say. Now that particular application is permanently stored, but this thing or this program file or this application or this file of PUBG that is available on hard disk, that file typically known as program, not the process, it's a program. Now when it will become process, yeah, so it's available on your screen of mobile, but you can't play with it. You can only see that there is one game available. But now what is process? Process, when you click on it, so that particular program, so this is a hard disk and there is a program called PUBG. It will move into the RAM. So the process of going to the RAM, or the process when this is a file that is present in the hard disk, is known as program. But as soon as that file, or as soon as that program, or as soon as that application file will move to the RAM, it will known as process. So CPU can't interact with hard disk directly. CPU will interact with RAM. So that is mandatory. That program or application will move to the RAM first, then only CPU will able to execute or like able to run that particular process. Why? Because why is CPU not able to run with the hard disk? Because the speed of hard disk compared to the RAM or compared to the this memory is very low. So the fastness in the game you can see in this world is because the game is running on the top of RAM, not on the top of hard disk. So input output operations are slow of hard disk as compared to the RAM. That's why first application will go to the RAM, and then from here CPU will run that particular process. So that is the difference between program and process. Now, why we need operating system? Because to store a program, you need hard disk. But to run a process or to run a program, so that program on RAM or is known as process, and to run that process you need RAM and CPU both. So exactly these two are doing exactly the computing things, exactly doing the computations things. So that's why they are known as compute units. Okay, and that's why it's known as storage unit, but storing something somewhere else, some like storing some applications, storing some program files, but they are exactly executing or doing computing. Now, why we need OS is, so RAM, CPU are under the hood for us. Why I'm saying under the hood for us is, so this is your laptop. In the laptop, RAM, CPU are there. On the laptop, Windows is running, and on Windows there is a game. Maybe this is PUBG or like Vice City. Any game is here. Now, if you want to run this particular game or particular program, you have an access to the hard disk. You can see what all the things are stored. But to run this or to play this game, you need to move this program first to the RAM and CPU. And as a human, you don't know the language of this RAM and CPU, like how to interact with the RAM and CPU. So if you say, if you just like an Indian guy, if someone says to interact with to Japanese or to Chinese, you can't. Why you can't? Because you don't know the language of Japanese Chinese. In the same way, you can't interact with the RAM and CPU because you don't know the language of RAM CPU, how to interact with RAM and CPU. So if you don't know the language also, you can't interact. That means you can't able to push that particular program file or application on the RAM and CPU. That's why you need the operating system. So operating system is nothing but operating system we can say is like a bunch of bunch of softwares bunch of softwares and multiple softwares are there. When we installed operating system, multiple file will get installed, multiple other software get installed with operating system, and like etc other things. So during the time of installation we see that multiple files are installing. So OS is nothing but a software only, or a bunch of software. And this OS will remove the silos. Silos is like a layer. Silos is like a layer. So the OS will remove the layer, or OS will remove the silos between the hardware and the human. Now human you can think of like this is a human, this is the hardware. So that is a RAM, CPU, etc. Other hardware things or other like resources, and OS is between this middleman. And you can think human as a program, and hardware you can think is like a Chinese guy, and you don't know Chinese. So how human will interact with Chinese guy? That's not possible if you don't know the Chinese language, or the Chinese guy will don't know the Indian language. Similarly, program will not able to interact, or like we are not able to interact with the hardware directly. So for that we need a middleman. Middleman is like some travel agents we can say, like those know the both Chinese and both Indian language. Here the role is played by the operating system. So operating system will know how to take that program, how to take that PUBG game to the resources. Maybe that is RAM, CPU. If that game needs some internet connectivity, how to connect with the NIC cards, so that OS will know. So the main final conclusion of mine is OS is nothing but OS is just a program, or it's like a multi-purpose guy that knows how to interact, or that will provide a, I can say that will provide a feature to us, feature to the humans, feature to the normal peoples, to interact with the resources or to interact with the hardware's resources that we can't able to do directly. Hardware resources in sense RAM, CPU, etc things. So that is like a layer, only a software or a layer to that will providing us a some ways or some way or some tricks to interact with the hardware resources like RAM, CPU, etc. thing. So this is all about like OS. And coming to the Linux OS. So Linux OS is again the same as like Windows, but like Windows is also a bunch of software, and Linux OS again is like a bunch of software, and from that bunch of software, one of the software is called kernel. So if you are aware of the great man called Linus Torvalds, so this is a guy that's not developed a Linux, so Linux OS, I can say. That guy developed one of the software that is coming with the operating system, that is called kernel. And kernel you can think like a heart. So without heart, a human can't work. Same like without kernel, Linux OS will not work. So now there are multiple we can say the use of kernel. Let me explain you few of the use case of kernel. Before that, you need to understand some two terminologies. That is user space and kernel space. So space is like you can think of just for the understanding you can think of like room. So there are two separate room, user room, kernel room. Now what is the use of these two rooms and why two rooms are there and what is the use of kernel? Let me explain to you. First, let me explain you the user space. So user space is the space or I can say the room where user can work, and the user means here is to us. So user means here to humans like us only. So there is a means of user space, and so let me draw a diagram for you. So this is a Windows, and down to this under the hood RAM, CPU, all the resources are there. On the top of this RAM CPU, the operating system is installed. Here in the case is Windows, or you can assume Linux also. And on the top of the operating system, we are installing multiple softwares, or I can say we are creating multiple files or folders. And these are like Firefox. This one is like PUBG. Yeah, so you can think of like these are the applications and these are the operating system. On the top of operating system, user is interacting. So we as a user are here, and we user can't interact directly with this RAM CPU resources because we don't know the language of RAM CPU and other things. So as a user, we can only interact with this above things. Like we can interact with Firefox, we can open the Firefox, we can close the Firefox, we can play PUBG, we can clip files, folder to manage the photos and videos, we can do this like of things. So user space, we can say to this particular box. Now exactly if you say the user space is kind of a space or a room or a location where normal user like we can do the multiple things, like we can run the application, we can manage the applications, we can close the application. Yeah, and kernel space is somewhere you can think of like is when we install this operating system along with this operating system, somewhere here the kernel as in software that is developed by Linus Torvalds is also installed, and so whatever things that is done under this space or under this particular room, there is known as kernel space. So this is a location. Kernel space is kind of a location where, like, when you open this Firefox particular browser, that particular flow is like user is opening Firefox. So that is a program that is under the hard disk. Now it's converted to the RAM for the process. Now when a user click on some particular application or program, this will make a call to the system. So it will make a call to the system is like it will tell to the system that I want to run myself. So give me some RAM, give me some CPU. So that particular system calls or that particular process handles or that particular process calls is handled by that kernel as a software. So this system calls are handled by kernel. And where this particular calls or system calls or process management is handled, that particular space or that particular room is known as the kernel space. And now there are many more, we can say, the features of kernel. Let me give you one by one. First you can see is like process, process management. So kernel space, or like kernel as a software will manage the process life cycle. Like you are running Firefox, so this is a program on rep. It's that particular Firefox program is a process. Another process is like PUBG. So it's not like that when you're playing PUBG, the backend things will stop, or the Firefox surfing will automatically get stops. So in middle, if you want to switch, it will both the things will work. So that process management, like how much time of CPU or how much space in the memory or RAM you want to give to that particular space or program, that is all is like process management is all handled by the kernel. Another thing is like device management. As soon as you sorry, as soon as you attach some device like pen drive, hard disk, so as a pen drive, hard disk, we can't interact, or like we can't that particular things are can't interact directly with the system things or system resources. So that thing is like launching some drivers or using the drivers. So all of things are like you like handled by the kernel. Another thing is like input output communication. So how that mouse or keyboard will communicate to your screen. So screen is normally known as output, and keyboard and mouse are normally known as input. So how this two things will intercommunicate with each other. This all the things are like managed by the kernel. So this is all about the kernel mode, kernel space, user space. What is the meaning of operating system? Why we need operating system? What is the exactly meaning of kernel in the terms of operating system? Who developed what things? Everything like like I told you. Now there are some myths that Linus Torvalds given us the Linux. That's true. Without heart, even is nothing. Similarly, without kernel, Linux is nothing. But yeah, for this video, it's all enough. And in the next video, I'm gonna tell you what are the architecture of Linux, what are the system libraries, what are the user application, what are the user utilities, how exactly things gonna work, what are the system calls, how many type of system calls are there. Everything I'm gonna tell you in the next video. So be continuing with me, and let's meet you in the next video.